All right. Welcome back. Hello, friend. And we're here for another week of more Haskell hacking and fun times. So thanks for joining me. This week we're going to be going again back on the adventure engine, I think. So this is a little interactive fiction engine for building interaction fiction games in Haskell. And we're, like a lot of the projects we do on the stream, are doing it mainly for learning how to build, what it's like to build actual programs in Haskell and not, I don't know, whatever people think it is we program with Haskell. So like more than just cute tutorials and stuff, right? So we've gone through from a console-based text adventure game with like kind of a basic REPL loop to a full GUI application that takes input and output and has like nice, well, not relatively nice UI and stuff like that for displaying your inventory, moving around. We're gonna add cool graphics and maybe even sound or something at some point in time. But today, what are we gonna work on today? Well, last we worked on this project, I believe we just got basic item interactions working so that you can, excuse me, lock and unlock, or at least maybe just unlock containers, which are game objects in the game. And that offers some new ways for us to implement some puzzles, some typical puzzles that you might find in such games. So I'm getting close to the point where I got enough tools, enough cool things we could do. I could probably flesh out a game and call it good. But there's a few things I think I still want to be able to do. Clean up some of these things, like some of the error messaging, doing the word wrapping on some of the log messages in the world. Want to be able to add scoring, rewards, things like that. We got to get rid of those hard-coded map data game objects. Part of the reason for doing this as like an engine is that we should be able to write some authoring tools to build game worlds with, and those would just load the engine itself would just load that data in and run it as a game. So we're getting close to that point. I feel like we probably just need maybe a couple more puzzle mechanics and some rewards and scoring, save file versioning, things like that. That would be nice. I think that's kind of a nice to have. And yeah, maybe some nice quality of life things like verb autocomplete, input history to go along with the scene history. And things like that. Which I think we might end up solving as part of scoring rewards. And you'll see when I have some ideas for how to implement that. We might work on tonight, maybe. I'm feeling kind of like I want to work on that. Replace the exit locks with our locks. That's another thing we should probably work on too. Yeah. That's kind of a thing you wouldn't really notice was replacing. It's kind of a quality of life thing, just code cleanliness wise. Low-hanging fruits. Let's see, object interactions. So we do have some item to item. We have some item to room stuff. Yeah, okay. I'm gonna replace the exit locks with the locks that we just made for containers and see if we can't get that working first. So let's get that. Let's get it. Projects. Let's open up our source code. That's the one. Yeah, okay. Source, adventure, engine. Okay, so locks. We have container lock. Exits. Exits have locks as well. Currently using, I think there's exit lock structure. Yeah, or maybe exit lock. And I think there might be a way to just use this lock structure to replace that. It has the same idea, key items, some fail text, some success text. It has the bonus of having a lock state, locked and versus unlocked, and that sort of thing. So similar to containers, data container. All right, we can have a maybe container lock. Now container lock has a different, we created a container lock record here because we wanted a different description of the container when it is unlocked, which we might want for doors as well, maybe. But we have an existing kind of locked unlocked behavior right now. We could just do that. If we want different descriptions on door locks, we can implement that later and do kind of the same thing probably. So let's go to the exit. Let's fire up the project to build. Fast, file watch, bang. And for the exit, I'm going to just replace exit lock here with lock. Maybe lock. We'll see what happens. Probably get a bunch of errors, which is what we hope for. Good. Let's jump to the first one here. Of course, it's not an exit lock anymore. It's just a lock. And that needs one more parameter, locked initially. And just here doesn't need the apply operator. We can get rid of that. There we go. And then the next type error is down here, pattern matching on exit lock, which we don't really need to do anymore. We have lock state now. So if the player has the key items, let's see, okay, we have a type mismatch error now. We're gonna have to figure out how to handle that. Because locks don't have entity IDs of items, they have entity IDs of game objects. Let's see, we can probably just fix that here. Entity ID of, oh, sorry, it's item IDs. Item ID. Yep. So, let's see, still got the type mismatch here. Entity ID of item, it doesn't want that. All right, the lock, just double check lock. Should be, let's see. A list of entity ID of game object. Okay. Okay, so that should be the first parameter to player. House key items should be game object. And this list here, game object, is also what's passed in from the lock. Cool. And then the lock state is unused. We should probably use it, otherwise, or we should ignore it and be explicit about that. So I guess when the player has the key items and moves through the lock, it should just switch to the unlocked state, of course. That makes sense. And then we can display the world log, the success text for that lock. Well, that's correct. So I think we just need to change the state, the state of that game object again, which is fairly messy to do at the moment, just because everything is so deeply nested. One of the to-do items I've been thinking we should probably put in here are lenses and prisms for game objects. I want to be able to set state of locks and other properties of the easily. Right now it's a bit of a mess with pattern matching everything out down to that level of like the lock. As we've seen with handling locking and unlocking. For example, we go to unlock a lock on a container, we have like this really gnarly match out and record update here. Which we're probably going to need for this as well. I wonder if there's like I can just kind of break this out. I'm going to copy it from something. Okay, so let's go back to that type error here where we're, no, other one, lock state. Yeah, we need to do something here. We need a helper function for setting or updating a particular item in the item database. Update current room, exit current room, get object in current room, get object in inventory, put object in inventory, get object. I should have like a modify object, I think. It doesn't look like I have something like that. So that would be a useful helper function, I feel like, for this case. Something like modify object. It wouldn't just be the entity ID of the game object. We'd have to pass basically the function we would normally pass to map.adjust, I think, which would be an entity ID game object to something, 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 something. Oh, it's right there. Bap. Yeah, so, okay, it's just A to A. Yeah, I think that's what we want. So, can even be A to A, I think. And then our map. Entity ID of game object and game object to that same map. In fact, we don't even need that. We just go world, I think. World would be fine. Oh yeah, we need the key though. So the entity ID of the game object. That's right. And a function to update the value at that key, and then we would just return the world. So this will handle like pulling the inventory out of the world and updating it. Pretty useful. Let's see, let's pattern match it out. Something, 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 something. Something. Objects is the second map. 1, 2, 3, 4, 5, 6, 7. Okie doke. 1, 2, 3. So it's there. Objects. 2, 3, 4, 5, 6, 7. There we go. We're going to turn the world where the world objects going to be equal to objects m.map, m.adjusts f object ID of objects we don't need that monad constraint, it looks like. Except, no, we might want to be an M world. Except T M world. Except T game error M world. Pure that up. What did I get wrong here? I could not match type A with game object. Right, because our callback function we're providing for F, we're providing like A to A, and this is a particular map where it's not anything, any A, it's game object to game object. It has a concrete type. Cool. Let's format that a little nicer. It likes that. Pretty good. Pretty good. Okay, let's see. Now, now we want to unlock the door, lock, and then move the player. So let's make this, can we make this a do block? Unlock door. And do we have exit and scoop? An unlock door. So I need an unlock door function of some kind. Let's remember where we are there. Jump over to the world. I believe exits are also in their own map. So we could do kind of a similar thing for that. I don't know why I added world objects when the exits is what we're concerned about. Here. So I need a similar function for that. Modify exit. Set of objects. It's going to be exits. Not entity ID but of game object, but entity ID of exit. This will be exit to exit. In fact, I'll just plop this over here. Exit ID. And that should be world exits. Should be good. Okay. Right. This is, I almost want to have like accept T over state now at this point. So I want to be able to write like unlock door, then move player, right? And add these actions that update the state of the world. To do that here transparently, but each one of them is kind of independently returning a new world result in just an accept T. Which, yeah, is not the worst thing. Keep going with it for now, I guess. But like now I got to do like world prime equals, you know, this hypothetical unlock door What do I have an exit ID? Exit name. All right, so we're going, in handle walk, we're going from a room to another room. So the exit from ID from this current exit is the current one we're trying to unlock. So this could be given the parameter of world prime with exit from of exit. And that will update the lock status, the lock state of the room. And then move player. In fact, we don't even need this to be a do at the moment. Still be in move player, but then we have like world prime prime. That should be fine. I almost want it to be a do block, but we can leave that for now. Yeah, so then we just need to implement unlock door, looks like. Unlock door. Entity of an exit returns a world. However you implement that, I'm not sure yet. That means we are going to continue ignoring lock state here, unless we want to pattern match on it. Oh, okay, sorry. Exit from returns the room. Let's see, what else can we do about that? I guess I'm going to need some way of not only modifying the exit, but looking up the ID of an exit by its name. Do I have something like that already? Get exit. No. Okay, so we have modify exit, get exit name, or by name, get exit ID. Not item. So it takes a world, text, the exit name, and returns. Yeah. Yeah. An exit ID, entity ID of an exit. And that's just looking into the map. Pretty straightforward. Don't know what error I'm going to throw in fetch there. Actually, yeah, I don't even know if I'm going to use fetch. Yeah. Fetch takes a map and a key and looks in the map for that key. Not necessarily what we're going to be doing here. Because we're not going to be looking up by key, we're going to be looking by name. So we're going to be searching the map. So we'll get the world, the exits, 2, 3, 4, 5, 6, 7. Or that's a lot. We'll just do W. World exits of W. Okay. And now let's look at data.map. Probably have something for finding things. Find in lookup. Something lookup, deleting, inserting, construction, query. So I was looking up keys. I think what we're gonna have to do is just like, oh, there we go. Filter, partition. In view, max view, I'm gonna look up, yeah, nothing to in the API for us to look up by value. Interesting. So we're gonna need to write a little helper function for that. Because what I want to be able to do is, yeah, the case, like maybe it returns maybe. Find in map, exit name, exits, nothing, and then we just return some error. Fix that should be a proper error. Otherwise, we find the exit ID, and we can return that. This is basically note, except we don't have find in map. Something Pam. I don't have note in scope. Okay. Note, I think is already defined in a Haskell library. We could probably just pull in. Very lightweight. Let's just find it on Google. Just in the errors package. Which I don't think we have. But maybe we do. Okay, so we'll just add it. Say here. Yeah. Let's see. So unlock door, still no good, but yeah, otherwise we're fine there. Except we need find in map. Okay, so let's add a little helper module for map related things. Adventure, data, map, /util.hs. Yeah, let's create it. Venture, data.map.util, where find in map. It's going to take, let's see, function, a bool, and a map, some key to A, and it's going to return maybe A. Import data.map, map, import qualified, data.map as M. That should be good there. Okay. So we have to pull in F into scope, and the map into scope. And maybe A. Okay, so then we need the values. Elms is the first thing we can do with it. And since M is going to be our final argument, we can do this point free. So now we have a function that we have to implement, list of A to maybe A. We have that in data.list. Find. So import that here. Find F. Actually, we don't want the A. We wanted the K. This isn't going to be quite right, right? So we wanted to return the key, the exit ID from the map, based on this function. This isn't going to be quite what we want. Stocks. Yeah, so that'll get a list of tuples of K to A. Oh, what's that function? I'm using the wrong one here, probably. Or wait, 2 lists. Probably be enough. We don't really need an ascending order. Yeah, we just need 2 lists, I think will be enough. Oh, wait, maybe KA, so find F, and then we have to do something else with it. All right, we need to reach inside the maybe. Now we got to bring back M. It's not quite what I'm expecting here. It says it needs to be a maybe KA to maybe K. Let me slow down here a little bit. And just take a step back to where we had the hole here. All right, we get a list of keys and A's. To maybe K. Well, I can do something with that. I can find with F that list, and then I get a function maybe KA to maybe K. Okay, maybe I can just do F map like this first. Okay, and it's just a mutil. Cool. Let's go with the engine. We'll import that. I'm kind of messing my naming convention here for my utils modules, but hey. All fine and dandy. We haven't committed anything yet, so we can fix that. Okay, so unlock door now. We were working on this one here. Right, so this needs to be function from key to value to bool. It's kind of a weird function, actually. Because if exit name of v is equal to exit name, that's true, but we have key there. We're just kind of ignoring the key. And this problem here, this type error, is that we have an either. It can't necessarily be treated as an accept T, or doesn't know how to do that, I guess. Mm-hmm. Interesting. Where is it located? Yeah. So this function is returning a either game error entity ID exit, and we want it to be an accept T, which is like kind of similar but not the same. So I was wondering if there's like a way to generally lift, quote unquote, a type of that type to an accept T. I assumed that it was the same thing, that we could just return a value of that type, and it would just be turned into the appropriate thing. But it's not. So maybe I need like a special handler function for that if this doesn't have anything, and I should just get rid of that dependency. Oh, lift either. Okay. Yeah, lift either. Yeah, okay. There's a, hopefully that works just fine. Yeah, okay. Phew. I thought that was a thing. Yeah, so find and map I find is a little bit weird because this callback function here takes the key. If this is true, we get the key back, but it's like the value's right there. Just seems a little funky to me. It works. Like I could hide the key, I guess, if we wanted to. And that would hide it at least, and that maybe it just doesn't look so weird. Yeah. Well, as long as the exit name is equal to that, we're good. So we have our get exit ID. Get exit ID from exit world and exit name. Pass that to unlock door. We'll have to do that up here. It's almost like actually exit current room. I should return both. Now that I think about it, now that I see the code on the page, that's what it wants to do. Right, I shouldn't have to do that in 2 actions because maybe that's why it looks weird. Yeah. Okay, so let's just get the exit ID here, and we'll make exit current room return the exit ID and the exit together. We'll make it like that. Entity ID of exit. Which will, again, break our types. This fetch is only get the value, and we want both. And there is, I believe there is a function for that. Really? No way. There isn't one? Oh no. This is fine. We get the exit ID. Fetch is the exit. We can return pure exit ID and exit. Comme ça? Bon. Good. Perfect. Okay, yes. So now unlock door. That all type check's fine. We just have to find the implementation for unlock door. To do that, to give us a new world where that door is updated. Modify exit, I think is what we called it, right? It takes a world, an exit ID function, returns a new world. Too many arguments. Let's see. That holds an exit entity ID. Exit ID. Oh, right. I got to bring that into scope. EID. Let's just call it EID. Why not? Okay, yeah, then this hole should be exit to exit. Cool. Except that's going to return in our accept monad. We don't really need that, y'all. Or at least we're telling Haskell we don't want that here. But I kind of do. World. What's this other type error? Oh, yeah. That's because I need to ignore the first element because it returns a tuple now. Okay. So now that whole should just be a function exit to exit. And yeah, unlock exit. Put a little function for that there. Happy little function, very small, very nice, very easier. We have to return an exit. Let's pull that in to scope. Okay. Exit. Let's pattern match it out. I want everything to be the same. I just want to get the lock part. I believe we have 5 arguments, 2, 3, 4, 5. Last one is the lock. Otherwise, we're just going to return it unchanged if it's already unlocked. So then we can use our record update syntax here. Exit, where exit lock is just lock, where lock state is unlocked. Some import shadow binding things from that. Super happy fun times. So we'll just use an explicit import for that one because that's the only function we use from it so far. And that's okay. All right, so that works. Let's see. Well, it compiles anyways. Let's try it out. So here's our game. Very cool. If you try to walk in the front door, it's initially locked. So we get the error message just like we did before. It's unlocked by having the shovel in your inventory. So let's pick that up. The pickup command, pick up shovel. So now we're holding the shovel and we should be able to walk through the front door. And we knock in the door with the shovel and we're in. So we can drop the shovel. We should be able to walk through the door. Now here's the thing. I'm not sure if this is going to work. If I walk back through the front door again, will I get locked out this time? Right. And it is. It's saying it won't budge because I no longer have the shovel in my inventory. So the only check we do is for that. That the player has the shovel in the inventory to get through it. So we're going to have to fix that. I kind of saw it while we were going through this. Did you? I don't know. Maybe you saw it too. So, handle walk. So we have just lock. And it does this check as a guard. Player has the key items. We really should also just move the player in the case where the door is already unlocked. We don't have to change the state of the door at that point. We can just move the player. All right, so this is where the lock is locked. And then we have to pattern match again to make that complete. Key items, error text, success text, unlocked. All right, we can simply move player. Exit, I think we have all that. Hopefully we have all those names in scope already. Move player, exit, player room, and world. We don't care about those at this point. 2, 3, there. So that should, once this compiles again, I think our scenario should work now. Where once we unlock the door with the item, we no longer have to have the item in our inventory in order to pass through it again, because it'll be unlocked. So we'll pick up the shovel. We can use short names here, which is P. Walk that front door. Okay, so we knock it in, we drop the shovel. We walk through the door. Now we should walk back through the front door again and have no problem. Cool. Kind of two birds with one stone, but there's not a ton of code. Yeah. Let's make sure we're still using that kind of stuff. And do a quick little review here of our work so far. So our main changes come here in the engine. We import note and our util module from maps. The main change here, of course, is changing this from exit to lock to just lock. That looks good. Exit room, exit current room returns the exit entity ID of the exit as well as the exit itself. That's fine. Couple of helper functions, modify object, modify exit. Yeah, change that, looks fine. So changing, let's see here. This hunk's changing handling walking, right? So we handle the case where it's locked and unlocked. That looks okay. Add a couple of functions for unlock the door, unlock the exit, so on and so forth. Yeah. Okay, let's commit that. So when applied, this change will replace exit lock with lock on exits. Lock type or modeling locks in the game world. One thing we should probably do before we commit this is remove the old exit lock type, since it's no longer used. Now, of course, this game engine isn't in production yet. It's not used by any users, except for myself, as far as I know, and maybe the few people out there who have maybe forked it and played around with it. One thing to note here is that we did, by changing this type, change the way it's serialized, the save game state. Since the save game state in this engine saves the entire world, like its database and everything with the save, and its current state, that means old versions that have the type we just removed will no longer, well, it should be safe-ish, but the point I'm trying to make is that when we change the types like this, we have to be aware that we're also, if we're cutting like a new version of the engine, be aware that we're changing the serialized state of things. In other words, the save games, and users might want to be able to still have a save in progress. They want to play with a new version of the new engine. At least that's my hope with this one. It's not always the case. Some game engines, that's impossible, and you just have to not upgrade to the new version until you're done with your save. Which is unfortunate sometimes, but I'm hoping to avoid that in this one anyway. So yeah, it's just something to be aware of. Like right now, we're not in production yet. We don't have users, so like changing types, I'm not so worried about. But thing to keep in mind for the future. Okay, so we remove that type. Everything compiles just fine. So that means it probably still works as well. Ooh, we should probably add that module that we forgot to commit. Fix up. So let's just rebase that. Wash that all together. Cool. That looks good. Go to our to-do file, and we're done with locks for now. Boom. Okay, that's that. We don't have a huge amount of time left, but I'm going to throw down a couple ideas. I'm just going to sketch up some stuff for doing the scoring, rewards, and finishing the game. Okay. So, where do I want to put this? Let's call it rewards. I'm gonna have something in here. So essentially, what we have when we're playing the game, right, is we want to be able to walk around, interact with the world, and in order to make it like a little bit more game-like, a sense of progression, a a way to kind of represent how well you did as a player is maybe not only just getting out, but your score as well is kind of sometimes used in adventure games and interactive fiction. So what I'm thinking for this is that certain actions in the world should come with some kind of score. Like when I bring an item to a particular place, or I unlock a particular container and solve that puzzle, I should be able to get some points. Right? The author of the game should be able to say, okay, you get 20 points for solving that puzzle. It's a 20-point puzzle, whatever that means. And cool. So I reward the player with 20 points. Same with like maybe bringing an item to a particular room or something like this. Whatever the case may be. Right? And how do we model that in this game, right? Like if I pick up the shovel, a simple thing might be like, okay, you picked up the shovel, cool. But maybe I use the shovel in the room and I pick up the weird coin. Well, that was kind of not obvious that you should do that, so maybe you should get 20 points for using the dig verb in this room. Right, so there's a kind of, there's a couple of things we need to track there in order to say like, okay, give the player 10 points if they use the verb dig in the front porch room. Right, or give the player 10 points when they get the weird coin in their inventory, even. Might be another way to phrase it. Which is that when certain things happen at a certain point in time, do this or award this. So what I'm thinking is that we can track certain actions the user takes as events. When they do a particular verb, we can record the parameters given to that verb. And like various things about that action to some kind of a event log in the game state. And so every time we pick something up, we walk somewhere, we drop something, something enters the inventory, something leaves the inventory. These could be all data structures that we record to the log. And then we could have another concept of a reward that can follow this log and watch for certain events that match. Right? When I see inventory item picked up event in the log, and it has this ID and this whatever, 10 points. That'd be one way we could do that. At least that's what I think that's my thing there. So I think we can basically have some kind of event log in the game state somewhere. So let's look at that. Game state. Here. All right, list of scenes, input buffer, game errors. All right, game state, event log. Some kind of type there. Game event, perhaps. What is game event? We could have item picked up, item dropped. Let's start with something small. These could have JSON instances as well, so we can like save the game state with this event log in place. Let's move the game events to maybe below these instances or before the definition, maybe before the definition of the game state. Yeah. So that's how I'm thinking about that. I'm just gonna add the to-do in here for this to serialize game event log, save game. Just gonna ignore that for now. So we have a list of game events, right? And then basically, like, how do we issue rewards for when certain things happen in the event log, right? That would be like some kind of reward function. Game event is our stream. We get to have some notion of, what would that be? The reward. Something like that would be the type. It seems pretty reasonable. And we want to be able to say, how can we, and we want the author of this code, of this game, to be able to specify with their game what the rewards ought to be. All right, so it's not straightforward how they would be able to do this because we can't serialize Haskell functions, and I wouldn't really expect the author of the game to be able to write Haskell. That's not the point. All right. So we want to be able to have like some kind of data structure then that matches game events to rewards. Event reward. How do we make that? Parameterize on it. Hey, can we still serialize that though? Goes event reward. This. It's the event reward event. Some integer number of points. Not necessarily any old integer, probably a positive one. But maybe negative is fine too. And we don't really care. Like, game authors might want to say, like, okay, well, if you do this thing, it's actually bad, so subtract some points. We allow the full range of integers, and yeah, you could allow that to happen. So this would be a way for us to kind of tie together different event rewards like this. So if we imagine just gonna like item picked up here. I'm just gonna write it here just to mess around with it a little bit. All right, so what would a thing of this be like? Our event reward item picked up 10. All right. Okay, that's kind of cool. Let's make item picked up take like an int item ID, an entity ID of some item in our game world. Say the item ID is 10, and we want to give them 10 points. Doesn't quite work because I got to put this in braces or parentheses. Cool. That still looks pretty good. Pretty reasonable. Cool. And so we want to do the reward function. We have a list of event. Let's say we have one type of event reward for now. What would even be this function? What does this even mean? I think we can only really match event. And since it might not match the reward event, this A doesn't even make sense being passed in here. Right, this only makes sense now if, say, the event and the event reward, the reward event and the amount, right? Such that the event is equal to the reward event, and then the amount. Otherwise, what should we put there, right? 0, nothing. Or we could not assume a default value. We could put like just int, or maybe int, sorry. Right, we can do just amount and nothing. Nothing having a little bit more of a understanding that the event didn't match the event reward. And really, I don't, maybe it's a little too general, so awarded some points or no award. awarded the amount, otherwise no award. Which doesn't take a parameter. Well, that's a little bit more clear. So then my score becomes a list of event. I can have a list of event rewards that the author would provide, and we basically sum that down to an amount or a total reward. And so we'll need some way of combining rewards, the amounts, in awarded amounts. Something like that. Okay. Scoring them like this is cool. Now, the question is, what does it mean to have like multiple 0 or more event rewards? Because in this empty case, right, this wouldn't even, there would be no way to make an award of any points. So that's pretty obvious. Otherwise, we have at least one event reward and we have the rest. And what can we do in this case? We could gather all of the rewards that match our reward function over all the events, take those amounts together and make that the value of reward, and then recur on the remaining event rewards until we get to the no award case. Or we could say it's awarded 0 here, because I'm thinking like we're trying to present a score here, which is a numerical value. In fact, it would just be 0. And so so let's, what can we do with that? We can do something with a map of reward, event reward. over all the events. And then we have a list of rewards that we have to get down to an int. So it looks like I need to flip some arguments around perhaps, but yeah, so list of reward to int. We can fold that down. With some, well, we'd need, yeah, I don't know if we could do it with some, because we'd need to have an instance for reward for that. But some function fold L prime with the starting element of 0. Which we import from data.list. Cool. Some reward. Int reward. Int score. If it was awarded some amount, then we can return the amount plus the score. Score, anything else, doesn't matter. It's just the score. We ignore them. That's no award. Awarded. All right, that takes care of that one event reward, but we need to recur on the rest. We still have to use the rest of the event rewards. So this isn't quite finished yet. Yeah, I'm going to keep that. We'll wrap a little function with our score and event rewards here. Events, event rewards. Okay. Go. It's going to take an integer amount, the list of event, and the list of event rewards. I'm just going to return an int. So let's this current event rewards sum over all the events. I'll just call it skr here. Skr plus. Sorry, this is going to be. This will be skr. This will be skr prime. Skr events and the current event reward we're inspecting and the rest, just as we had before. And then we add skr prime plus the natural recursion of go with the current amount. No, we don't need to do that. I don't think. Yeah, we pass skr prime into the natural recursion. And events and rest. No, we do need to include the running tally so far and what we just summed from the current reward that we're looking at. AVTs, name shadow binding, fun times, there we go. Okay, now that's non-exhaustive because we need our base case. So we'll take the score, and when we're out of event rewards to check, that's our value. Okay. Does it calculate the proper score? So item picked up. Sorry, item picked up. Say it's 1. Item dropped. Item picked up 1. Okay. So we picked it up twice. Now, what if we have an event reward for item picked up? That's 1. We want to give them 2 points for that. All right, and so the score here is going to calculate 4. And it does. So that's kind of weird, because now if I pick up the same, if I just keep picking up and dropping this item, picking up and dropping this item, picking up and dropping, I'm going to continuously get a reward for doing that. Which is probably not what we intend when we're writing this reward system, right? We want to have a notion of being able to say, like, only when it's the first time that we encounter this event in the stream, count it. If we've done it before, don't. That's going to be trickier to do. But I think we're kind of out of time in the stream this week. So we're going to have to think about this a little bit more and model this a little bit better. But I think we're on the kind of the right path. Right? The idea, we just have to modify our score function so that when we match an event reward, we only do it, like, I think part of it's going to be fold L here, but we only do it once, is the idea. And I have to think about this a little bit more too, because maybe and I have to think about this in terms of the game design. Do I want to be able to have puzzles that can be rewarded multiple times? Or is it universally true that as soon as a reward is received, you should only get it once? I think it's generally true in most games I play, and the game I'm kind of thinking of. So, yeah, something to think about there. Any hoozle, we'll get back to this next week. Of course, I do these streams Tuesday nights regularly, and around 8 p.m., 10 p.m. on the Eastern time zone. So you can follow me on Twitter at Agent Ultra, or you can, of course, subscribe here. If you're watching on YouTube, same deal, you know what to do there. And follow along. And of course, we also have a Discord server through the awesome declarative.tv site there that you can get onto the server there. And we have a channel for this stream where we can hang out, We can talk about your project. We can talk about this project. We can talk about any of the projects we've done on this stream. And you can also meet other cool people from different programming languages and other streamers as well who do this sort of thing. So give that a try and check it out. Thanks a lot. May your monads always be free and may your types always check. I'll see you next week.